That's so much better right there, for sure. So the first thing we're doing here is for each of the door panels, you'll need to remove the armrests, which is a Phillips, and you have to put a good amount of force into making sure you don't strip the screws. That's all that holds them in, is those two. And then we'll use a plastic trim remover to remove the door panel cards. And then we also have to remove one small Phillips in there, and then this trim piece comes out. So now we have to work our way around with the pry tool. There are clips that this just pushes in. So we'll work our way around and just gently pop those out. We'll work our way around all the way, going around and then up. And then the only thing holding this in on the top is a metal piece that sandwiches down. So once we get all those pieces popped, we'll need to lift up. But since that switch is still in there, the wires will be holding it to the door. So you don't want to just pop it off and drop it because it'll pull on those wires. So just be cognizant of that. And then so once you get all of them, and make sure you get the ones that are up here high, and then once we have all of those, it should lift right up. The challenge with the back door ones is going to be the trim piece right here, and it's easier to remove the back ones with the window down. So that's what we're doing. And then it should just lift right out. And then you have the connector right there. So to take the door card off, you can just unplug that and you're good to go. On some cars, if you are either the second owner or you did this yourself, applying the vapor barrier, we won't need to take that apart. As long as there's no modifications and the connector is outside of the vapor barrier, you should be able to leave this be, unless you want to actually move the wires back in there instead of them being stored there. The way this works is once you have the boards have a removable connector. So to remove it, you push on this. They only go in one way, you can't reverse it. And these are keyed, which means that you can't get it off by one. So it only goes in one way. And all the harnesses are pretty long, and the reason why is just in case you want to do your own thing with it, right? Like you could leave this long and mount it somewhere else, or you could, if you want it really trim, you could just cut it wherever, and that's going to be completely up to you. But the way it basically works from the factory, the way the switch works is that this blue wire carries power, carries 12 volt from the battery, and when you press the switch, contacts touch and transmit that energy to the motor. Basically, the way that works is you have two metal contacts and you have 12 volt on one side, and then you have nothing, which is what's called the load, on the other side. And when those meet, energy flows, and then your motor turns on, and it'll either go up in one direction or down in the other. So that's the basic principle. It connects 12 volts either to the motor plus and minus, or to switch direction, it switches that polarity. And what causes the slow, there's three things that can cause the slow windows. One is the switch thing, which I'll explain in a second. The second is an old or dying motor. And the third is like window tracks or window runs that are dried out and causing a bunch of friction as the window moves up and down. So the switch issue is addressed by this. Basically, since all of that current, power is current times voltage, all of that current is passing through the switch contacts, those metal contacts that are touching, every time you press one of these to drive the motor. And the motor takes about 7 amps. You have 7 amps passing through those contacts, and what happens is as they get close and touch, a little arc goes between them, called arcing, and then over time it develops almost like a charcoal on each surface, which is called pitting. And then what happens is as that charcoal almost thing builds up, as the pitting builds up, you'll get more what's called resistance or impedance, which affects how much current can get to the motor. So the contacts will still touch, but imagine instead of 2 nice pieces of metal, you have 2 pieces of metal with a bunch of charcoal on them. And it gets to the point now where actually no current can flow, and your window either moves really slowly or doesn't move at all. And so what this does is it will offload all of that current carrying to these 2 relays, which are automotive rated for, I believe, 40 amps or 30 amps. And the switch will only switch on if the relay turns on or off. And this will carry all of the current, meaning that the pinning issue will stop, and this will only carry about the 40 milliamps needed to switch these relays, and the relays will carry the 7 amps needed for each direction of the motor. So 40 milliamps, that's 0.04 amps versus 7 amps. That's almost 100 times less current going through this. So that's the principle of how this works. You'll see a bunch of wires here. We don't need to use all of these. The way that this is going to install is it effectively sits in between the switch and the switch side connector. So the vehicle side connector, unless someone's messed with this, you don't need to do anything. We'll only be doing things on this side. We have power and ground. So red is going to be power on the board side, and that will connect to your blue. Ground, if you don't have like an aftermarket speaker installed, we will need to ground this. So you'll have to break this out, and we can show how that's done, and then make sure it's grounded to somewhere that's metal. So this is all painted, which means it's not going to be able to actually ground. You have to do it onto like an unpainted surface. So one way to do that is on the interior where it's not going to rust. You could actually scratch off or sand a little bit of the paint. You could either drill, or you could mount it to an existing place in the door that's bare metal. Things like this, where it's like bare metal touching bare metal, are also totally fair game mounting locations. It basically just has to touch part of the chassis that is just metal, not painted. And then these other ones we'll insert, and basically the way they work, these other four, so blue, white, green, and yellow, the way they work is that when you press that switch, it tells the relay, I want to go up or I want to go down, and then one of these wires will tell the relay, turn on, and then the other will take the current from red, from power, from the battery, pass it through the relay, and send it out to the motor. So that keeps your switch only using a small amount of current, and then this carries the rest. So that's basically how this works, and we'll be inserting this in now with some crimps. We are going to be cutting 3 wires, blue, which is going to give us power, so that'll go to our red, green and yellow, and then red and yellow. So I have 2 tools here. This is a small wire cutter. You can just get these at any hardware store. The only reason I have 2 is because this one, which I'll have links to all of this, doesn't have a wide enough opening up here to cut these easily. But we will be using this for wire stripping. So this is a really nifty tool. I'll show how this works. So you just put in the wire, decide on your length, and then just squeeze, and it strips it. So you don't actually have to mess around with any of this stuff. The only thing to think about here is this is still going to have to mount like this. So ultimately, where you decide to cut and crimp, my advice would just be pick somewhere in the middle. You don't want to pick close to here, because if you ever need to redo this, and there's a crimp here, if you need to say connect something else, or you just want to actually remove this from your system entirely and reconnect these, to remove that crimp, you're going to have to cut it out, and then you're running out of wire here. So to give yourself flexibility, cut as close to the center as possible. So we're going to pick these 3, and this is the scary part. Remember, you're going to have to crimp on both sides. So if this foam thing is stuck here, for this, I'm just going to try and leave everything as original as possible. You could cut on this side too. You could cut on this side. It doesn't matter. It's the same wire. So I'm going to leave a little bit of space to do the crimp on this side, a little bit of space, and then a bunch of space here in case you want to modify the system in the future. So there's no science to this. The other thing to mention is that if you mess up one of these crimps, you might have to try a couple times, especially on the first go doing it. What I would suggest is, since these have so much wire on them on purpose, just practice with it. Maybe take off a few inches, like we could do this right now. Take off a few inches, practice stripping if you've never done that before, and then you can practice a couple crimps, which I'll show how to do actually on this test wire. So these are cut. What we'll do first is this practice crimp, then I'll strip these all, and then we'll crimp in the system. So this kit has, this is just something I bought on Amazon. I'll include a link, but 3 sizes. So the way to do this scientifically is to really just eye it. So for this gauge, a red is probably fine. When you start actually wanting to run like multiple wires together, sometimes it might get tight, and so you might want to pick a bigger one like this blue. And then the yellow is pretty excessive. The diameter of that's pretty large. Won't need that. So we're probably going to be working mostly with the red or the blues. What matters isn't the color or getting it perfect. What matters is that the crimp stays in. So I'll show you two examples of that. So we'll take a blue, and when you put this in, a lot of these will have a little ridge where it's hard to see, but it'll prevent the wire from going all the way through, in theory. The challenge is that to get it to actually not go all the way through, you need to do two things. Instead of having the wire frayed, you'll want to take just your index and your thumb and then just twist it. You don't have to go crazy hard, but you want it to, when you tap on the edge, it shouldn't fray. Ideally, if it's not filling up the entire diameter, you can also bend it over. So that's another trick you can use. So you'll have to take off a bit more to do that. And then I do the twist and then bend over. And so that'll take up more space. So that's another trick you can do. So we see the red is probably a great fit for this diameter, probably not for that. So I'll show two different ones. So we'll put it in, and then you should be able to see it actually stops in that little barrier. And now this tool, this is a handy one. The way this works is you basically just put the crimp in, or the, I guess it's called a butt connector, and then you line it up, and you literally just squeeze, and it'll get it effectively, perfect every time. What matters is where you do that squeeze. And so the thing where some thought comes in here, and you have to just, think before you act, is where's the wire in there, and then where is it actually going to be pushing down, right? So you see it's going to be pushing down with these teeth. And generally what I like to do is there's going to be two ridges here. It's a smaller cylinder, and then it kind of fans out a bit. I like to crimp just like a little bit past that area where it fans out. So like right about there, and then you'll get something that looks like that. So we can do one as an example, and I'll show you the test that I like to use. So we put this in here, and then give that a squeeze, and sometimes you need two hands. And then the test you want to do is to pull on it. So you don't have to pull crazy hard, but you give it a small tug, and it's not going anywhere. So that means in your vehicle, when there's road vibrations, or if it gets caught in something when you do the reinstall, it's going to be okay. And I'll show you an example of what happens when you crimp poorly. So as an example, one thing we can show is, let's say we pick one that's too big with a lot of space to fill. And then so now you match up to color. So this is a blue, and I'm going to do a partial. And then I have to release this. It'll let me. Okay, so that shouldn't have done all the way, and then it just pulls right out. So you want to avoid that. Visually, it might look fine, but you always want to do the tug test. And this, you can actually pull, you should be able to pull pretty hard, to the point where, like, I don't know, I'm pretty strong and I can't even pull that out. So you don't have to go that extreme, but that's really the test you want to do on every single one you do. So this is, once you do a couple, it's pretty simple. What I would suggest is there's plenty of extra wire here. Take off a few inches in practice. But now we're actually going to move on and do the crimps into the system. Okay, so now what we're going to do using all those techniques is we're going to strip all of these, and then we are going to crimp in the butt connectors using this tool. So one thing to think about before you start doing your stripping is how much wire you actually want to go in. So you don't necessarily need exposed wire past where the metal is, because if you notice, the metal is only in this inner section of the tube, not in this fanned out section. And you can just look inside of it. And so you don't actually need, you can, it doesn't affect anything, but you don't need there to be metal the whole way. So typically for something like this, it's about 1/4 inch, maybe a little bit more. So you can target between, 1/4 inch and give a couple millimeters. So I'll just quickly go through and do all of this. And again, this tool is really nice because it won't actually strip out any of the metal. It'll just take out the rubber. And again, there's no real science to this. You know, you can always take off more or remove a bit if you take out too much. One thing to mention is that the gauge here is marginally different. And so we may want to actually remove a bit more and do that twist that I had talked about, and then use the larger connector. So we'll see once we get there. So I'm twisting these so that they don't fray. And this one, yeah, there we go. Okay, so we've done all of them on the board side. Now we're going to do these on the car's wires. So you can use the same exact tool. You don't have to change any settings. So you're going to pull about a 1/4 inch, a little bit more is fine. These are typical Toyota high quality wiring. So these are copper, they're pretty thick. By default, they're really not going to fray, but it's always good practice. Just give it a twist. And then on this side, I would like to preserve this foam just because it's original, so I'm going to do my best to get this in one shot, but I made the mistake of not leaving myself enough room on this side. So what I would have done to do this again on the next one is I'll probably cut on this side, maybe more in the middle, just in case. Because if you get a crimp wrong or you need to redo it, it's always good to have some extra room. And all of these connectors actually you can repin all of these, but it's just kind of a pain, and so it'd be nice to avoid having to do anything like that in the future. Just leave yourself some extra wire. Okay, so now we have all of these stripped, and now we are going to match up where everything needs to go. So the only one that is not going to be connected to this is going to be the ground. So the mapping here is that red will go to this blue, and then blue will go to green and yellow on the switch side. So that's the switch side. And then yellow will go to green and yellow on the connector side. So that's over here. White will go to red and yellow on the switch side, and then green will go to red and yellow on the connector side. One thing to note is that we have cut this blue, but you'll notice we're not connecting anything to the blue on the switch side. What we have to do here, so remember, this is the switch, right? This is the termination point. This is everything coming from the car and then stuff going back to the car. This blue takes battery 12 volt from the car, so your power is actually coming in here, not in here. What we will need to do is basically, effectively, you could use a splice too. These are just to reduce the number of things you need. I just decided to do this. We will basically be crimping in like that. So you'll be pulling power off of this, and then we want to reconnect it back there. So we'll start doing that, and the trick here, whenever you want to combine two wires, is kind of wrap it around a bit and then just twist. So give it a twist, and then you don't need to do any tug or anything like that, but just make sure that it's that they're both touching. Now what I'm going to do is I'm going to look to make sure this is the right diameter. It looks good. And then the trick is you kind of rotate a bit. You don't just jam, rotate a bit. And then you want to place your finger, because if you don't, the wire might actually push it out. So I'm going to rotate and then peek, make sure it's actually in there. It is. Then I'm going to take the tool. I'm going to look. I'm saying, okay, it's going to be a blue. I'll place it where the metal part is, and then crimp down. And then here's that tug test. So you give it a little pull, both are in, so we're good on that one. So now we'll connect it to the other side. So again, I want to make sure it's not going to fray. And then you can get these other ones out of the way when you're doing one. It's always more challenging. The first one is always the easiest, like on, you know, that side was easier. This side now you have all this stuff you're balancing. Since I'm right-handed, I like to get in a position where it's easy for me to just, you kind of got to play a little bit of Tetris. And then I come back in with the tool. Again, I'm picking the blue one. And then since this does, I want to make sure I put a good amount of force, so I'm bracing it on the tailgate and then just pushing down. And then I give it the tug test again. That feels good. It's not failing, but I did feel a little bit of movement. Remember, this has 2 wires in there, this has 1. So just to make sure that this never has a problem, I'm going to come in there with a conventional crimping tool. I'm going to put it on the blue, and I'm going to just give it a couple squeezes to make sure that it's really secure. And that should be good. So that is, we will repeat it for all of those, and then test it. Okay, so we did the power. So we have red going to the blues here. And now on the switch side, so we have red and yellow. And that will be going to white on the board side. So we can pick the one that has less space. That's going to be the easier side to do. Or sorry, the first one will be the easier side to do. So you want to make your life easier. This side is harder because there's less wire. That was my mistake. And what we will do is start on that side because of that. So same thing. I'm going to put it in. I'm going to make sure it's actually in there. And it is. I'm going to get this out of the way, all this rest of the stuff. Take the tool, put it in the blue, brace, and crimp. Give it a tug test. It's good. So on the switch side, the red and yellow goes to white. And just to make sure, since this is a little bit bigger than the gauge of this, I'm going to actually remove a bit more material and then do that bend over I was talking about of the wire to take up a bit more space. So I actually have not quite an inch, maybe 3/4. I'm going to bend it over. And now you see I've effectively made a bit of a thicker wire. So I'm going to get this stuff out of the way, insert it in there. And then you're going to want to make sure you hold everything together, right? Because if you let go, this stuff it'll just come apart, right? So what you don't want to do is end up, it falls out and then you crimp and then you got to redo it. So just make sure you hold everything together. So I'm going to come in and I'm going to put pressure on that wire and hold it. And then this is kind of the dance. You can hold it with the tool a little bit. You don't want to squeeze. And then you can turn and rotate and looks like it's in there. It's better to mess up the board side because you can just redo that than it is on this side. Give it the tug test. We're good. So now we're going to do the other 3. So again, green and yellow on the connector side is going to connect to yellow on the board. So I'm going to take another blue one. And then we're going to check to make sure it's... The other thing is you don't want, if you take off too much and the little bump inside there doesn't catch it, what happens is that this will go all the way through like that, and then there won't be any space on the other side to do your other wire. So it's helpful to look before you crimp instead of just doing it blindly. Usually that bump is only on one side. It doesn't go the whole way. It's just like on the bottom. So that looks good. So I'm going to hold it like that, just so it doesn't move. Put it in the blue, crimp down all the way. Tug test, so we're good. And then that was green and yellow on the connector side. Or sorry, green and yellow on the switch side, which goes to blue on the board. I'm sorry, I was mistaken. So that goes to blue on the board. Red and yellow on the switch side goes to white. And then green will go to red and yellow on the connector side, and yellow on the board side will go to green and yellow. So We have not made any mistakes yet, but it's always good to double check before you actually crimp. So same thing here, we're going to remove a little bit more of the material, and just so I don't take off any metal, I'm going to actually start a new one. So maybe 3/4 of an inch. You see it's frayed. I'm going to grab that, just give it a twist, and then stick my thumb in there and just kind of bend it over. You don't have to twist it again, but you can just kind of get it into shape. It should look like a question mark. And then again, it's always good to like triple check. I have OCD, so this might just be a me thing, but it's a lot easier to make sure you're right than to fix an error. So on the switch side, we have green and yellow. That should go to blue, so we're good. So I'm gonna twist that in there, and then grab this, and then make sure it's actually in. Now I'm gonna do the crimp, so push down, give it a tug, and we're good. So now we've done everything on the switch side. What we need to do is the last two on the connector side. And so like I said, being that these are a good size for the car's gauge, but a little bit bigger than the board side gauge, I am going to redo these with a little bit more material removed so that we can do that bend over. So again, about 3/4, pull it off, twist, and again, if you pull off too much, it's fine. You don't have to restart down here. You can just cut it off where the wire is. And again, you can also just bend it all the way back. You don't have to if there's extra. Okay, so there we go. All right, so on the board side, green is going to go to red and yellow on the connector side. So since this has less wire, it's going to be more of a pain if we do it second, so we're going to do this first. So again, twist into place. Take a blue one, get the wires out of the way so that you don't cut anything accidentally. And then crimp down, tug test, so we're good. Okay, so red and yellow on the connector side is green. So again, push it in, give it a little rotation in case it got caught on anything. So that's one of the tricks, is just rotate it a bit, and once it stops pushing in any farther, you're good. And then typically it's very hard to, like, you're basically holding three things. You're holding this, you're holding the wire, and you're holding this. So unless you're like well practiced, this might be frustrating. So just remember that it's okay, like, to hold the thing with the tool so that you're only holding two things at a time. That could make it easier for you. So see, I'm just holding it with the tool. I'm not squishing anything yet, but still take that wire, do that rotation, and then you're going to want to crimp down all the way. And the prettiest crimps, of course, are like perfectly lined up like this, but as long as you have, you know, a full crimp down, it doesn't matter. So the fact that this is like this and that's like that, it doesn't matter. All right, so we're on our last one. So green and yellow on the connector side is going to go to yellow on the board side. So I'm going to get all the wires out of the way, push this in. It's getting caught on something, see, it doesn't want to go in. So that's because it was a little bit frayed out. So I'm going to rotate that. And so now we're good. And then if it gets caught, like mine just did, and you can't get the tool out, one thing you can do is, instead of committing to the crimp and then having to cut it, go to the place you haven't crimped yet, and you can just, and if you can't release the tool, you just do a dummy crimp and then pull it out and restart. So if it gets caught and you can't get the release to open up, don't waste good wire. Just move over to the empty part, crimp, and then the tool will auto release. This is just a tool I like. You can use whatever you want. So give it a pull. And then this is our last one other than the ground, and the ground will need to go to the car chassis. Well, we say chassis, but really anywhere that's metal that's not painted. So we're not going to be crimping that into anything unless you already have something like for speakers running to that area, and then you can crimp to that. Okay, so everything should be in. If you want, because this is going to be in the interior, there isn't really a risk for any type of corrosion or anything like that. But if you wanted to be extra crazy, you could put heat shrink on this and just hit it real quick with a heat gun. The wires that the harness company built with this, I'm not sure what the temp they're rated for, so just heads up, don't go too crazy. But that's the only other thing you could do. Other than that, we're done, and it's the exact same for all the other doors. The driver's door does not need this. It already has a relay for the auto down, so you're only going to be doing 3. All right. So this will give the motor the amount of power it needs, but if your tracks need to be lubricated or there's a sticky section, it won't be able to fix that. Or if you have a motor that's on its way out. So this is one of the 3 possible things. So before you actually install it for good, you're going to want to put the switch in first before hooking everything up. If you hook everything up, then because this has to go to the body of the car, you'll have to remove it and redo this. So it's fine to test it on its own, but for your actual install, you'll want to put the switch in, all the wires, get those routed first, and then button everything up. So we just got this installed. The tips here that this is you got to hook this in first, and then this side will go in really easily. It's got a lip. This, to get the trim to properly sit over, is a pain. You can use these tools to help get it over. It's easiest to I'll post a tool that you can kind of hold the whole thing up and do it. But if you don't have that, it's easiest to kind of work it in slightly, because the lip here isn't that big. So once you get it over, this will all be sitting, and you'll see that if this is unlocked, the panel, the door card will sit probably right about there, and then you just got to push it down so that it lines up with all the places that mate, and then you just push it back in, and then we do it in reverse order. So this is going to go back in, and make sure to just put a good amount of force into those Phillips so you don't strip them, and then we'll install the trim piece there. So all of these should just push in nicely, and if they don't, usually it means they're not fully aligned. So making sure that everything's lined up, and then once it is, just pushing it back into place. So we're making sure that the board is tucked into a place that doesn't push out on the door panel card. Now pushing all of the tabs back in. Now we're installing the trim piece around the door handle. So once that goes in, just remember the Phillips. And then the last thing we have is the armrest. And so when you're tightening these, you're probably going to have to put a good amount of force into these to get it to properly tighten up against the door. So to make sure that you don't strip it, just you can either grab the door, hold on to it as you push, or just push really hard. But they'll probably need a good amount to feel secure. And then just test everything one last time, and then should be good to go. So all of the doors are going to have basically the same process, but what we're doing is removing the front passenger right now. And to get it to de-seat, you have to just shake it a little bit. It's the same thing. It has some clips. And then you're going to disconnect the factory connector. And just watch your, when you hold this, just make sure that you either get a buddy to help hold it so that you don't have to put strain on the wires. And these old connectors are going to need a fair amount of coercing. So when you remove them, jiggling them around side to side helps as you remove them, and then try to put most of the force, if not all, on the connector part rather than pulling on the wires, because those might pop out. And there we go. So watch this. This lip is sharp, so when you handle this, just make sure you don't cut yourself. But it's just the exact same process as the other one, and then these switches, the way they come out is the same. So it's just this tab. Don't be afraid to bend it. They're strong. So once we finish that, we're gonna then route all the wires back through the door. Just make sure your switch is oriented in the right direction. The way to tell is that it should be angled kind of like that. And then we're just going to bend back those retaining tabs all the way. And then you can get a buddy to hold it up while you get all the ground stuff connected, and then we'll get it back on. So after you get everything installed and ready to go, we need to figure out where to connect the ground. We have a ring terminal here, and so you want something that contacts metal. These bolts behind here insert into a plastic insert, so those won't be any good. And then the other things you could do is you could drill a hole into the body, but if you don't want to do that, this bolt holds the window track frame. What we have decided to do is, instead of removing this bolt entirely, which the frame here uses that as support, and then having to realign that, which could be a pain, we've decided to cut the ring terminal into a U shape, insert it there, and tighten it up. So you can buy those straight from like AutoZone or anywhere, so you don't have to just get a ring terminal and cut it. We're just doing that so that it's easier. It is easier because it doesn't have that trim piece on the side. So once you get the lip up and over and make sure that lock comes through, then really all you have to do is push down. And this is easiest to do with the window down. So then just making sure everything lines up in the right holes, and you can start pushing things back into place. And then we'll do the trim piece for the door handle, and then we'll put on the armrest as well.
That's so much better right there, for sure.